Hey guys, we started earlier in the week talking about the slopes of lines. And so today we're going to take that slope and put it together, and we are going to write the equation of lines. So there's two main forms that we are going to focus on. So our slope intercept form is y is equal to mx plus b. Okay, now here, remember that m is your slope and B is what we call the y-intercept. Okay, I also want to point out that sometimes you can be given the y-intercept as a point. So sometimes you may see the y-intercept as a point that's like 0, comma, and then some number. This is also the y-intercept, right? Because the y-intercept is the point along the y-axis when x is 0. Okay, so sometimes you will see it just where it'll tell you the y-intercept is a number, or it might tell you that the y-intercept gives it to you as a point, but that's still, that number right there would represent b. Now we also have point slope form. So y minus y1 is equal to m times x minus x1. Now this is when we are given a slope, or when we can calculate the slope, and we have a point. So our point would be x1, y1. Okay, so notice that the names of them tell you what information you need in order to be able to plug into that form. If I have the slope and I have the intercept, either I've been told it's some number or I've been given it in a point form, then I can plug directly in to slope and intercept. If I am given a point and a slope, then that's when I use this form. So I have my m as my slope and my point is here, the x1, y1. Now, I want to kind of go over, we talked a little bit on Monday and Tuesday about lines that have zero slope and undefined slope. And so those are our horizontal and vertical lines. So the equation of a horizontal line is y is equal to b, where b is the y-intercept of the line. So when we look over here at this horizontal line, we see the y-intercept there is -3. So our line would have the equation y is equal to -3. Now, I want you to make a kind of mental note that horizontal lines are lines that have a slope of 0. Okay, so over here we have the line y is equal to -3. Sorry, it's hard to see that. Okay, then vertical lines, they are always in the form x is equal to a, where a is the x-intercept of the line. So over here, I can see my x-intercept is at -2, so it's x is equal to -2. Or I can write it over here, x is equal to -2. Sorry, that box is kind of low. Okay, and then what I want you to understand and make the connection is that vertical lines, these have a slope that we either say it is undefined, or sometimes you'll see it as no slope. Okay, so no slope and undefined is not the same as 0, because 0 is that horizontal line. It's still a function. But whenever we have a vertical line, it is actually not a function. And so that's when we talk about it is undefined or no slope. That's when our slope ends up solving out to be a number over 0. Okay, so remember, we can't have 0 in the denominator. And so that's why our slope here is undefined. Now, let's look at some examples here. All right, so here I have a slope of -2 and a y-intercept of 6. All right, if I have a slope and an intercept, then I can use slope-intercept. So I've got y is equal to mx plus b. We know that m represents slope, so y is equal to -2x. And then my intercept is 6, so I'll write plus 6. And that's it. That was an easy one, right? When we're given the slope and the intercept. Next, we have a slope and a point. So if we have a slope and a point, we are using point slope. So I've got y minus y1 is equal to m times x minus x1. So we're plugging in the x and y point to our y1 and x1, and our m is the slope. So we have y minus, our y1 is 1, is equal to 3 times x minus 2. Now, notice it asks us to put our answers in slope-intercept form. Now, this is in point-slope form, but it's not hard for us to make it into slope-intercept form. We just need to distribute that 3. Y minus 1 is equal to 3x minus 6. And then we're going to add this 1 to both sides to get the y by itself. So I have y is equal to 3x minus 5. And that is our equation with a slope of 3 through the point 2, negative 1. Okay, now we already did talk about a slope with 0. Okay, a slope with 0 is a horizontal line, and it's a y equals line. Okay, and it's the y equals line whatever the y value of the point is. So we can just write the equation y is equal to 6. Okay, so it's going to be important for you to remember which one of these has the horizontal, like if it has a slope of 0 or undefined, and kind of memorizing 0 slopes are y equals lines, undefined slopes are x equals lines. So since it was 0, it was a y equals line. Okay, now this is probably one of the trickier problems that you might see. Now, when we see this, an x-intercept of 2 and a y-intercept of 3, so many of our brains want to make this the point 2, 3, but it is not the point 2, 3. So remember that the x-intercept is where it crosses the x-axis. So we're over here at 2, and the y-intercept is where it crosses the y-axis, and we're up there at 3. So you notice that these are two different points. They are the points 2, 0 and 0, 3. Now, we have not come across one like this where we weren't given a slope, but we know how to calculate a slope. We were worked earlier this week with the formula for slope, that y2 minus y1 over x2 minus x1. So now I'm going to plug in my points. So I'm going to do 3 minus 0, so 3 minus 0 over 0 minus 2, and we get negative 3 over 2. So it's 3 over negative 2, so that would kind of make the whole thing negative. Now, the thing is that normally we would, like, if we have points and a slope, we would use point slope, but look at what we were given, that y-intercept. So we can just jump straight to slope-intercept form. So y is equal to negative 3 halves x and plus 3. Okay, a few more examples. Now, we talked about this a lot last class, so I just want to kind of put it in front of you again before we start trying to write these equations. So remember, parallel lines have slopes that are the same. Okay, parallel lines have slopes that are the same, and perpendicular lines have slopes that are opposite reciprocals. So again, we focused on that on Monday and Tuesday, so hopefully you remember that. Okay, now here for these examples, we're going to write our equations in slope-intercept form. Okay, remember, slope-intercept, y equals mx plus b. Okay, now when we want to know if a line is parallel to something, then we need to pull out what the slope is of this equation. So remember, y equals ms plus b, that's what form this is in. And so we look at that coefficient on x, that right there is our slope. So we know that the slope of this line is 5. And so we know the slope, and now this is the notation that I couldn't get my computer to do the other day. The slope of the parallel line is also 5 because it's the same. So now we have a slope and we have a point, so we will use point slope. So y minus y1 equals m times x minus x1. So we're plugging in here y minus 4 is equal to 5 times x minus 1. Now, if we want it in slope-intercept form, we just need to do some simplifying here. So we're going to distribute that 5. We have 5x minus 5. Add our 4 to both sides. Y is equal to 5x minus 1. Okay, over here, we want to know the line that's perpendicular to this line. Well, we still think about it the same way. We need to know what the slope is here. It's always the coefficient on x. So if our given slope is -3/4, then the slope of the perpendicular. Now remember, they are opposite reciprocals. So that means we need to change the sign. So if it was negative, it will become positive and flip the fraction. So there's our new slope. So we've got y minus y1. Now this is a -4. So remember, minus a negative, remember negative is always going to give us plus. So that's a +4. I just changed it to. Is equal to -3/4 times x minus 6. So again, we're putting it in point slope form. Nope, slope-intercept form, excuse me. So we're going to distribute. We have y plus 4 is equal to -3/4 x. And then we have a negative, so it's going to be positive. Now, I want to remind you what's happening when you multiply a fraction by an integer. So I've already taken care of the signs, so I'm not kind of paying attention to the signs right now because I know a negative is a positive. But if I multiply this by 6, remember, all constants, all integers can also be written as a fraction over 1 because 6 divided by 1 is the same as 6. So then I multiply straight across the top and straight across the bottom. So I have, 18 over 4. And so that doesn't quite come out evenly, right? So that's okay. Oh, you know what, guys? I'm sorry. I wrote this down wrong. It should be positive 4/3. Excuse me. Positive 4/3. I was like, I thought this worked out evenly. So, excuse me. So we're going to change that. It should be positive 4/3 because it was the perpendicular slope. Thank you. Sorry, I didn't catch that earlier. So a positive times a negative is going to be a negative. Excuse me. So 4/3 times 6 over 1. Now that works. Multiply straight across. 24 over 3, which is 8. So it's going to be minus 8. Now we're going to move our 4 over. Sorry about this messy mistake. So 4/3 x minus 12. So I'm going to say something was wrong. I practiced that problem and it worked out right. So we just forgot to plug in the right slope. So our perpendicular slope would be that 4/3, 4/3. And so that works out when we distribute it through. All right, last example. So write the equation of the line perpendicular to 5x minus 6y is equal to 7 and through the point 6, -4 in point slope form. Okay, now when we look, this line is in the form, it's called standard form. We're not going to focus on standard form very much this year. So we're just going to basically take this equation and we are going to go and put it in slope-intercept form so that we can pick out what the slope is. So I'm trying to get my y by itself. So I'm looking to make this line in the form mx, y equals mx plus b. So the first thing I'm going to do is subtract my 5x. Goes away over here. I have -6y is equal to -5x plus 7. Now I'm going to divide by -6. So y is equal to a negative divided by a negative is positive. 5/6 x, and then we'll just leave that as a fraction. -7 over 6, because we don't really need that part. Right? So what is the part that we need? If we want it to be perpendicular to this line, and remember, we need that slope here. And so once we've got the slope, we have the slope and a point. So we're going to use point slope form. So y minus a -4, so remember minus a negative will make it positive, is equal to 5/6 x minus 6. And it just wanted us to get it in point slope form. So that is our answer. All right, we'll see you in class.